Ever wondered why understanding computer fundamentals is crucial, especially for computer science students and tech enthusiasts? Well, these foundational concepts are like the skeleton key that unlocks the intricate world of modern computing systems. From the binary number system to computer security, each principle forms a piece of the complex puzzle that is computing. With a firm grasp on these fundamentals, the door to advanced studies and meaningful contributions in the field swings wide open. So, let's dive in and explore the world of computer fundamentals. Starting with the basics, we have the binary number system, the language of computers. This system represents data using only two digits, 0 and 1. For instance, the decimal number 5 is represented in binary as 101. Remember, in the world of computers, it's all about 0s and 1s. Next up, we have the yin and yang of computing, hardware and software. Hardware refers to the tangible components of a computer, like the CPU and memory. Software, on the other hand, is the intangible set of instructions that control these components. Think of Microsoft Windows running on a Dell computer. In essence, hardware is the body of the computer, while software is its soul. Now that we've covered the basics, let's move on to more complex topics. Operating systems, or OS for short, are the backbone of any computer. Think of them as the middleman between the hardware and software, managing resources and providing essential services. Some well-known examples include Windows, macOS, Linux, and Unix. Next up is data representation. At the heart of every computer is binary data, represented by zeros and ones. These bits of data are grouped into bytes, with each byte consisting of 8 bits. For instance, the ACII code uses 8-bit binary numbers to represent characters. Moving on, we have computer architecture. This is the blueprint that defines the structure and organization of a computer system. The von Neumann architecture and the Harvard architecture are two classic examples. Then we have algorithms and programming. Algorithms are like recipes, providing step-by-step procedures to solve problems. Programming, on the other hand, involves writing instructions in a specific language to implement these algorithms. For example, bubble sort and quicksort are algorithms used to sort data. Data structures are up next. These are the building blocks that organize and store data in a computer's memory, allowing for efficient access and manipulation. Examples include arrays, linked lists, stacks, queues, and trees. Networking and communication is another pillar of computer science. It involves connecting computers and other devices to share resources and information. Communication protocols, like the Transmission Control Protocol, Internet Protocol, or TCP/IP, set the rules for data exchange between devices. We then come to computer security. This involves measures to protect computer systems and data from unauthorized access, damage, or theft. Encryption algorithms like AES and RSA, firewalls, and antivirus software are all part of this domain. Lastly, we delve into ethical and legal issues. This is about the responsible and moral use of computers and technology. It also covers laws and regulations governing computer use, privacy, copyright, and intellectual property. And that's a wrap on the more advanced topics of computer fundamentals. Let's recap what we've learned today. We dove into the world of computer fundamentals, exploring binary numbers, hardware and software, operating systems, data representation, computer architecture, algorithms, data structures, networking, and computer security. Remember, understanding computer fundamentals is not just about gaining knowledge, it's about building a strong foundation for innovation and meaningful contribution to the field of computer science.